academy. Let's consider a very important question on work, energy, and power. The question says, a car of mass 800 kg moves at a constant speed of 36 km per hour up an inclined plane of 1 in 8, full stop. The top of the hill is at a horizontal distance of 128 meters from the initial position of the car. Find number 1. The work done by the car in getting to the top of the hill. Number 2, the power at which the car works. So let's solve this problem. First of all, let's consider what work and power means. Alright, let's start with work. Let's start with work. Now, in science, work is said to be done when a force moves an object through a distance in the direction of that force. Okay? When a force moves an object through a distance in the direction of that force. Now, mathematically, work done, that's W, is equal to the product of force and distance. So you can say work done, W, is equal to force times distance. Of course, the SI unit is joules. So work done is measured in joules. Let's look at the next concept there. Power. What is power? Power is simply the rate of doing work, or the rate at which work is being done. Alright? Mathematically, power is equal to work done all over the time taken to do the work. So that becomes, we said work done is measured in joules, all over time is in seconds. So we can say power is measured in joules per second or watts. So I have power in joules per second or watt. Now here's one important derivation about power. We just said power is equal to work done all over time. But we said work done or work is equal to the product of force and distance. So work done becomes product of force times distance all over time. Force times distance is same as work done. Okay? If I work on this now mathematically, this is equal to, I can rewrite it as saying power is equal to, shift the force out of it, becomes force times, this gives you distance over time. Alright? Of course, since the distance is the specified direction, we can call it a displacement, right? Call it displacement. So record that we said speed, or perhaps velocity, V, is equal to displacement over time. So what does it mean? It means that from here, power is equal to force times displacement or distance over time is same as velocity or force. So I'll replace this one here with V, that's velocity. That means power is equal to the product of force and velocity. So I have this. That means power can be calculated in two ways. You now get power by dividing work done with time, or you get power by multiplying force and velocity. Whichever one will give you a correct value for power. Alright, so one more thing. Before we solve that problem, please, one more thing. If I have an object, now here's an inclined plane. Here's an inclined plane. Let's say we have this angle here as theta. Alright, we have this angle here as theta. If I have an object of mass m, an object of mass m placed on an inclined plane, of course, the weight acts vertically downward. So we have that weight is equal to mass times gravity. What's important to note is this, that the force that moves a body up or down an inclined plane, the force that moves a body up or down an inclined plane is given by F, and this F is equal to mass times gravity times sine of this angle here, theta. Very important. So the force that moves a body up or down an inclined plane is given by F, which is equal to mass times gravity times sine of theta here. So very important you note these three concepts. Alright, so with these three concepts now, let's solve the problem. So let's now solve the problem. My first task will be to list out my parameters. So what am I given? I am given number one, the mass of car. The mass of the car, that's M, which is equal to 800 kilogram from the question. Also, they said it has a speed. It has a speed. Let's use velocity or speed, that's V, to be equal to 36 kilometers per hour. So I'm having this. Alright, so I have it said an inclined plane of 1 in 8, right? I will tell you what 1 in 8 means much more later. But our first task here will now be to convert this from kilometer per hour to meter per second. So I'll have that velocity is now equal to 36. To convert this from kilometer per hour to a value in meter per second. How do I do conversion? This will now be equal to 36. To convert this, simply multiply this value by 1000 and then divide it by, in an hour you have 60 times 60 seconds. So this now gives you in meters per second. From here, this will be equal to this is a value of about 36,000 all over. This gives 3,600. So my value gives me about, this cancels this cancels this. I have about equal to about 10 meters per second. So I've gotten the velocity as 10 meters per second. Alright, so if I've done my conversion, what next? I'll try to represent the information on a diagram. So I'll have a diagram like this, something of this nature. From here, so I'll have this as my diagram. Try to draw an inclined plane like this. Then I have this. Alright, so we said a car somewhere at this point is trying to move up an inclined plane. It's trying to move up an inclined plane. So here is the starting point of the car trying to move up an inclined plane. Alright, so we have that the velocity of the car V is equal to 10 meters per second after the conversion. Also, they said the inclined plane is 1 in 8. Now, when they say 1 in 8, what does it mean? Now, when they say 1 in 8, 1 there represents the vertical distance, that means 1 meters, and then 8 represents the horizontal distance, and that's about 8 meters. So this is what is meant by 1 in 8. What's meant by 1 in 8? But actually, they are not necessarily meters actually. Alright, it's just what we use in getting this angle. So this becomes 1 in 8. So here's 1. Here's 1. From this point to this point, you have this as 1. Then this becomes the 8 there. Alright, this 1 in 8 are not actual distance per se. Alright, we need these figures, of course, to get this angle here. Because we need the angle of inclination between the car and the horizontal. So in cases where you're given the value of theta here, you will not be given 1 in 8 or something in something. So let's say if I was given 2 in 5, for instance, here will be 2 and here is 5. Alright, so the first one here should be placed on the vertical axis, that's vertical distance, while the second should be placed here. So for 2 in 5, here will be 2 and here will be 5. If I was given 7 in 15, for instance, here will be 7 while here will be 15. Alright, that's how you analyze this. So 1 in 8 means 1 should be on the vertical distance and 8 on the horizontal distance. Now I've said these are not the actual distances. Alright, we just use these to get the value of theta. So we'll call here theta. So we have this. Alright, so proceeding, we have that says the top of the hill. Now here's the top of the hill. Yeah? So the top of the hill is at a horizontal distance. Now what we say horizontal will mean this. There's the horizontal line. Alright, that's the horizontal line. The top of the hill, that's this point, yeah? Because we trace this as this point, we said is at a horizontal distance of 128 meters from the initial position of the car. Now don't forget, the car is traveling from here up to this point. So you can say from the top of the hill, that's here, to the initial position of the car, which is here, that becomes this distance here, this one. So you're looking at from the top of the hill to the initial position of the car, which is this. And don't forget we're saying the horizontal distance. So I will not take this one, no, I will take this one instead. This becomes 128 meters from this point up to this point. So I have this as the distance. Of course, I could still simply bring this one here, down here. That means the actual value of my distance from here up to this point, the actual value is about 128 meters. So I have this as my actual value. Alright, so we can ignore this one for now. Just to make the diagram much more appreciable, I will take off this one here. So I'm taking this off now. Alright, so we are here. This becomes the actual value of my distance from this point up to this point. So what next? We have to find two things. We have to find the work done by the car and the power of the car. Don't forget we said work done is equal to force times distance. Alright? So first of all, I'll have to get my force. Next up, I will have to get a distance. Now mind you, the distance we'll get will be the distance the car traveled. The car is traveling from this point here, this point here, this one here, up to this point here. So this becomes the distance the car traveled from this point to this point. So perhaps let's label this D. So here becomes D, the distance of the car. My label is going outside my diagram, so just take that one off. So I have this distance. Alright, so here becomes my distance. So this is the distance the car travels from this point up to this point. That's the distance. Alright, first things first. We said work done. The work done by this car is equal to force times distance. Let's say D in this case. The force that moves this car up the inclined plane multiplying the distance moved by the car. Alright, so what next? Let's get the force. Now don't forget that in this case now, it's now an inclined plane concept. And we said the force that moves a body up an inclined plane or down is given by F. And F is equal to mg sin theta. That's mg sin theta. Alright, so let's take up this now. If I look at this here, I'm having a triangle. I'm having a triangle of this form. This, and here's theta, this one here. The actual distance here, or let's put distance here. From here, we can get, if I take 1 in 8, 1 in 8. From here, of course, since this is a right angle triangle, I can use the idea of SOHCAHTOA. Since it's a right angle triangle. From here, I can see opposite and then adjacent. Of course, opposite and adjacent should be TOA, and I'm using tan. That means tan of this angle theta is equal to opposite 1 all over adjacent 8. Of course, when it comes to finding force, I need sine of the angle, not tan of the angle. So how do I get sine of this angle? It's as easy as I will get this point here using the idea of Pythagoras theorem. So let's call this x from Pythagoras theorem. It says that the square of the hypotenuse, that's x squared, is equal to the sum of the square of the other two sides. So it becomes the sum of this square, 1 square plus this square, that's 8 square. So I have that x squared is equal to, this gives 1 plus 8 squared is 64. So this is equal to 65. So I have that x squared is equal to 65, such that from here, x is equal to the square root of 65. So this value from here to here is equal to square root of 65. That's the value. Alright, so if you've gotten this now, from here you can get the value of sine theta. That means sine theta is equal to, sine is, if I use so, sine is opposite over hypotenuse. Opposite is 1 all over hypotenuse is here, that's root 65. Alright, so if I have this, no big deal. I've got the value of tan theta as 1 over 8. I've gotten sine theta as 1 over root 65. Let's also get cos theta. Cos theta will be equal to, cos is car. Alright, cos is car, that is adjacent over hypotenuse. From here, if I take adjacent, that's this part here, it becomes 8 all over hypotenuse. That's this. That becomes root 65. So I have that tan theta is 1 over 8, sin theta is 1 over root 65, and cos theta is 8 over root 65. From here now, I can easily find the force. So force is equal to mass. I have mass, gravity. In the question, we are asked to use gravity as 9.81. So what's left is sin theta. I have the value. That means I can easily find force. Next up, I'll have to find distance. This one here. So how do I get this distance here? From here, now don't forget we said 1 and 8 were not actual distances. They were not actual distances. We only use the idea of 1 and 8 or 1 in 8 to find the value of tan theta, sin theta, and cos theta. Now let's now work with actual distances. To work with actual distances, I would have to still reproduce this triangle. So I'm having this triangle now. Considering actual distances, here becomes theta. So I'm having here as theta. For actual distance from here to here is about 128 meters. So here becomes 128 meters. I'm looking for this distance here, that's D. The distance traveled by the car from the bottom of the hill to top of the hill, and we call it D. So I'm having D here. Alright, so how do I get D? From here, considering this angle, here is the here's opposite, here's adjacent, and here's hypotenuse, okay? Yeah, so I'm having adjacent and hypotenuse. That becomes cos. So I'll take cos of theta. It means that cos theta is equal to adjacent 128 all over hypotenuse. That's D. So I have it. Alright, so impute the value of cos theta. We said cos theta is equal to this. That gives you about cos theta is this is 8 over root 65. This is cos theta is equal to 128 all over D. So I'm having this form. So let's get D. It's as easy as cross multiply this and this. So this multiplies this. That gives 8D is equal to this multiplies this. That gives you 128 root 65. From here, D is equal to 128 root 65 all over 8. So divide both sides by 8, you get D. From here, D is equal to, I want to get D in 2 decimal places. So let me use my calculator. From my calculator, I have that D is equal to 128 root 65 all over 8. So in 2 decimal places, okay, so let me use 3 decimal places instead. In 3 decimal places, D is equal to 128.996 meters. This is the value of D in 3 decimal places. Alright, so if I have this now, I can now get the work done and the power by the car. Alright, so let's now get the question finally done. So number 1, we have that the work done by the car, W, is equal to force times distance. We said force is equal to mg sin theta, and the distance after calculation was 128.996. So I had this answer. So therefore it means that work done is equal to force, which is this. So I'm having mass times gravity times sin theta, here's the force, times my distance is 128.996. Alright, so in impute values, this is equal to the mass is about 800 kilograms. It becomes 800 times gravity is 9.81 as given the question times sin theta, so you can see here, is 1 all over root 65. This is sin theta. Finally times this one here, 128.996. So I have this one here. Alright, so the work done is now equal to multiply all of this. If I take numerator, it gives me 800 times 9.81. So 800 times 9.81 times 1 times this, so times 128.996. That will give me about 101,2360.608. So I have this all over 101,2360.608, okay, all over this root 65. So the work done is equal to, if I divide this, I have 101,2360.606. Okay, 101,2360.606 divided by root 65. That gives me about 125567.88 joules. Approximately, I have 88 joules. Alright, so let's convert this in terms of kilojoules. From here, take 3, 1, 2, 3. So if I place my dot here, it becomes 125 points. Okay, from here, 1, 2, 3. So 125 points. Approximately, this is about 6. Then it becomes kilojoules. So I have this as the work done. So hence, the work done by the car is 125. That's 125.6 kilojoules. Or you could simply leave it here, it's correct. The B part said to find the car. Now we just said, or we derived that car is equal to force times velocity. Alright, so that's now equal to force is mg sin theta multiplying velocity. That was 10, so I'm having times 10. Alright, so this value is equal to mass is 800, so 800 times gravity is 9.81 times sin theta is 1 over root 65. This times 10. You punch this to the calculator, you have that the part is equal to that is 800 times 9.81 times 10 all over square root of 65. So it's about 9734.25 watts. So I'm having this. The pi is measured in watts. We'll also give this value in terms of kilowatts. So in terms of kilowatts, this will be equal to, move this as 1, 2, 3. That will now give you 9.73 kilowatts. So this becomes the power. So therefore, the work done by the car in moving up the hill is 125.6 kilowatts, and the power used by the car in moving up the hill is 9.73 kilowatts. So this is how you solve this problem.